All right, what's up, everybody? Welcome back. It's Wee Man Da Vinci. It's been a long time since my last vlog, since last season. I got a pretty early start on the outdoor season this year, which felt nice. I was able to do indoor starts and get my compost also going early, and also do a lot of the groundbreaking work for the new 10 by 20 organic produce garden going in the back. And you know I wanted to take the time today. It was really nice out today. I wanted to make a video this evening about something very important that still now, and I think everybody, it's a forever learning process, because every plant's different. Diagnosing plants when typically a lot of times would be already considered past the point of beyond return. And so I want to show you, sometimes stop, don't throw that plant, that plant in the compost pile yet. So these are some dianthus pinks, and I want to show you basically a before and after. I had another pot. There's several pots of these on the front porch that my dad and I got from the hardware store, and these, all their blooms pretty much are dead, are shriveled up. Majority of gardeners would say that they messed up and these died. Well, I have good news. That is not always the case. After the correct diagnosis, these two plants, this is no gimmick, these two plants were the exact same shape as the other two, and look at them today. This is less than a week after the treatment that was recommended was implemented. And this wasn't from no specialist or any paid, anything just by recommendations. I just mean from my own general research, the things I've learned and things I've learned from going to school recently. Basically, there's a couple things everybody can do in order to just basically do an accurate diagnosis of a plant before deciding to throw things on it, or to take things from it, or to, even worse, just decide that it's done with, So the symptoms of this was obviously stunted growth. It was making no progress. They were shriveled up, they were brown, they even lost their green color, which means they were no longer photosynthesizing in the at least in their blooms, so I recently acquired my Blue Lab soil pH pen, which I love. I highly recommend this. Unfortunately, I do not have a code to offer you for a discount on these. I wish I had, but I am loving this. It was worth every penny, man. So the soil pH is the potential hydrogen available, and I'm gonna break that down for you. All that means is, if there is plant food in reach of the plant's roots, unless the pH level is in the correct range, then the plant cannot access those nutrients, even though they're within reach. There's a lot of science going on behind that, and basically it's called nutrient lockout. And I'm not going to bore you or throw you off with some, very complex terms and stuff, but I love soil science, but I can definitely make this something that everybody can apply. Most plants want a pH from 6.0 to 7.0, and that's because 7.0 is neutral, and most plants want slightly acidic. And so when I did my pH test, the soil was testing at 6.7, 6.6. So I knew that at this point, if everything that it needed was within reach, that it would be uptaking it fine, and it would look a lot better than it did already. So I knew from the pH tests being pretty much in the green that this was a different problem than nutrient uptake. So that leaves pretty much all the time, other than pest and disease pressure, that leaves aeration or drainage. And that either equals, you know, soil compaction, lack of soil structure, or that means lack of oxygen at the root zone, the rhizosphere. And that can come from several different things. Now, this is where it could get crazy and get confusing, but I'm gonna simplify it. Regardless of the cause of the shriveled up flowers, they were definitely because they weren't having enough oxygen. Whether it was because the soil did not have the right materials and components to drain regularly enough and easily enough, or if it did not, or if it was just plain getting overwatered to where there was not that time in between waterings for oxygen to replenish the root zone. They both could cause very similar looking bad results, you know. And so a lot of gardening is trial and error, and there is a lot of time and plants that can be saved by knowing how to decide what to try with an educated approach instead of just assuming and trying, you know. You don't need to get an expensive pH pen in order to tell this. You can look up the slurry test, which is as simple as a couple scoops of soil in a glass with some water added, and then testing that with a more simple liquid nutrient solution, aka liquid pH pen, which you can get much cheaper than soil pH pens. And you can also just get a couple $1 pH testing kit with pH strips, or the General Hydroponics brand pH test bottle of liquid drops. You know, you just take some of the liquid from that slurry test and put it in a little container and put a couple drops of that pH fluid on there, and then depending the color that the liquid turns, you compare it with the chart on the bottle and you can tell your pH, and that's accurate and quick and relatively easy, and it's available to everybody. That's on Amazon, that's at Walmart, that's at Ace Hardware, that's at your little garden center down at the corner. Yes, it's called pH test. You can also get the rapid test soil kits that test for NPK, which is nitrogen, phosphorus, potassium. That's the 3 macronutrients that all plants need. It might be micronutrients, and the rest of the 15 or so elements that all plants need are the macros. But the 3 big ones are nitrogen, phosphorus, potassium. That's NPK in that order. So you know, you can get the little, it's like a Tic Tac jar, and you put your soil in it, and then they have stuff for the nitrogen, stuff for the phosphorus, stuff for the potassium, but you put one in there and shake it one test at a time with the soil. You know, 3 different samples, 1 for each element, and you can essentially see what is it your soil is lacking from that test as well. So I recommend those if that's your only way to go about correctly diagnosing the circumstances of your plant's illness. Now, with that being said, let's get started. I tested, all right, so after testing a pH, it was apparent to me that it needed a new environment. So I used the ingredients to build from scratch some brand new soil that is organic and living, which is living soil, which is known nowadays. And that is my favorite method. So I took Pro Mix High Porosity Blend, which is peat moss. It's sphagnum peat moss with perlite, and I mixed in 1 part that with probably 1 whole bale of Pro Mix. Well, I'm not going to go into that whole mix, but for this container I used about 7 gallons of Pro Mix, and I used probably 2 cups of worm castings, and I used one of my favorite products I need to show you, APSU Supercharged. This is a very good all-purpose. It's 556, that's the NPK, that's the nitrogen, the phosphorus, the potassium. This is organic dry amendment. This is not liquid you mix up in water and it washes away and ends up in the water with the fish or in the well with your drinking water, you know, next week because of rainstorm. This, you know, builds soil structure and nutrient retention and stays around and slowly breaks down by biology, microbiology in the soil, and feeds the plants over time. You know, organic dry amendments carefully mixed into the soil are much better than fast-acting liquid synthetic nutrients. They're more natural and healthier for the plant and a more native uptake style to them than the synthetic chemical counterparts of these organic inputs. Now, with that being said, I mixed my peat moss, perlite, and worm castings for my organic matter, 1 part drainage, 1 part organic matter, 1 part peat moss. That builds a very solid soil structure. It drains good, it replenishes oxygen when water drains through it. Now, this is the result of those plants in less than a week after after transplanting them to the correct type of soil build that has plentiful minerals and nutrients and micro biodiversity for the plants to thrive on. Now, the most important ingredient here is the MYCORRHIZAE inoculant. It's called MYCORRHIZAE fungi or mycorrhizal inoculant. When you hear it called mycorrhiza, that's referring to the relationship that this makes with the plant roots. You see the plants and roots in this picture here? If you ever seen plant roots, if you hold the plant up and you see hairs coming off the sides of the plant roots, that itself is mycorrhiza. And it is this mycorrhizal fungal inoculant forming molecularly bonds with the plant roots to make extensions of the roots so it can reach further and access more nutrients and more water. So they grow faster, they grow healthier, they grow more fruit, and you guessed it, it even tastes better. Like the fruit, the vegetables and fruit that are produced after being inoculated with mycorrhizal fungi are like significantly more nutrient dense, which is very, very important. Now, so I prepared my holes here to transplant 3 of these, and all I do is make a little hole, you know, for the to make room for the root ball and whatnot of the existing plant. And you only need like a tablespoon of this or 2 per transplant hole. But you know, you just kind of, you know, just layer the surface of the transplant hole you're going to use with this mycorrhizal inoculant, and there's not really much that could go wrong as long as you do not overwater your plant. And you know, it's very easy to tell when it is time to water your plants once you know what to look for. Like for example, right now when the soil is just at a steady, idle, moist but not watered consistency, like it'll hold its shape without dripping, but that's about it. It's got a nice dark color to it. It's not like light brown or red or clay. You know, the darker it is, typically the more organic matter. So I want to take my garden trowel here, and you always water first, because you cannot transplant roots that are dry. They are bonded to the soil particles in order to put tension on the soil particles to pull water. So it's capillary action. And so even if they don't need to be watered, you need to make sure that you know, the root ball is going to have moisture when it separates with the soil that it's been in contact with. And you just want to go all the way around, even if it doesn't feel like it needs you to, just to make sure you're not pulling off any of the deep tap roots that dive vertically to follow the water table. Now, what you want to do here, and you can tell, see, this isn't dead because the roots, they are actually white. They're not brown or black. Let me see, can I get this focused? These roots sticking out, they are actually bright white still, even though the plant was not doing good above ground. This sucker still wants to live. It has plentiful white roots. It's got a root system. It's ready, but although, you know, despite that, no success up top. Now, what you can do is take some of the water-soluble kind of the mycorrhizal inoculant and kind of sprinkle it on the root ball, just a little bit. It doesn't take much, but that just adds some immediate inoculation, you know. Doesn't take much at all. I also, when I mixed in my APSU Supercharged and my mycorrhizal granular, remember you want granular to mix into the soil, and you want wettable powder or water soluble for making instant compost tea, or just mixing it with your water to water it to the plants. They're both important. And humic and fulvic acid, this is important stuff. This naturally chelates your minerals when there is, and your nutrients when there is more than the plant needs at that moment. In order for them to not wash off, it's important for the soil to have CEC, which is cation exchange capacity. You'll hear it called cation exchange capacity. And you know, cations pretty much, you know, they bond with nutrients in their elemental form, and they retain the nutrients and hold them, and they're staying in them like a hotel room. Like, you can add and add and add plant food all you want to a plant, and if it's not able to, if the soil doesn't have the exchange capacity to hold any more molecular bioavailable plant food, then it will just keep leaching out whenever it has free access to leave with water. So it needs to have nutrient cycling capabilities, and in order to do that, it's got to be biodiverse and biologically alive. Living soil, organic, and nothing, no disturbances. This is no till. You know, once you build your your soil, I don't know why I said service. Once you build your soil, you reuse that soil bed, you know, grow after grow, and it gets stronger and stronger. You don't disturb it, you don't till, you know, like when you build your soil correctly from the start, it will reward you time and time again. You know, you owe it to yourself just to try. So, you know, I already added humic and fulvic acid when I pre-mixed this soil, and worm castings, the APSU Supercharged, and come on, the mycorrhizal granular inoculant. So now what I'm doing, here it is. I have my tote ready of my pre-mixed, inoculated, pre-charged peat moss, perlite, worm casting, living soil blend to kind of, you know, backfill my plant here as I, you know, fill it in. You know, I just kind of, you don't ever want to pack your soil down on the plant. You just want to, like, loosely just let it fill the space and kind of move the leaves out of the way. But you don't want to ever push on it. You don't want to pack the soil down and pull up on the plant. And please, in a couple days, don't ever check the plant by pulling on it to see if the roots have took, because the immense damage that does, really, it's just not worth you know, it didn't matter if you did that or not anyway. If it rooted, it's going to show you in another day or two, if you can't tell already anyway. And if it hasn't, you're just making it a longer wait. So, you know, you're an impatient person if you're feeling you need to do that. So the quickest it could be, do yourself a favor, just, you know, do it correctly. Let them have time to root, and don't get impatient and tug on them. It's all about being patient. One thing I've learned with gardening is it teaches us patience. It's rewarding. It rewards us for good, hard work. And honestly, it makes me feel good when I do it every day. It feels like I'm giving back, because, you know, I see people litter all the time, and I see trash everywhere, and I see, you know, like food in the grocery store that's pretty unattractive looking, and it's not even cheap. And I'm wondering, why do we need daily vitamins? I mean, why is there children with diabetes and stuff like that? Like, it's because all of the synthetic agriculture, you know, we need more living, organic, sustainable permaculture gardening practices to be able to feed us and to be able to sustain the human race, you know, as a whole. The only way possible is if more and more people know how to take care of the plants that are caring for us. The only other thing I really want to show you in this video is how to water these in, because you don't ever pack the soil down. The first thing people want to do when they are transplanting a plant is they want to pack it down like it's going to blow away or get up and run off if they don't do that. But honestly, like, you have to water it in to activate the inoculation and to activate the roots in the new soil. So that's mandatory, and that compacts it enough. That actually causes a cycle when you do it this way and you don't compact the soil, and you just correctly put them in there and just fill the space without packing the soil down. When you water it in, you'll see the pores of the soil as the water seeps through it. It'll be almost like bubbles, or almost like sparkling on the soil surface. Those are air pockets opening up as air is following the water as it's streaming out through the bottom. So when you water your plants, water them slowly and go around the edge of the pot, so the roots follow the water to the outside of the pot and then down, and that way the water has time to seep into the soil before you put more. So do it in little, you know, give them time to swallow and take that gulp of air that comes in behind the water, and then give them some more. And then again, you know, and you want to fill your pot when it's dry. And then that way, you know, when you come and you want to check if your plant needs to be watered again or not, you can feel the pot again and see how light it's gotten. That's how you know how dry it is. And then you do the finger test. Stick your finger into the soil, and if your finger comes out clean, like all the soil was dry enough to just not stick to your finger, well, you need to go deeper, at least 2 or 3 inches, because if you don't have a mulch layer, the sun is going to dry out your top inch every day no matter what, and cause the soil to look like it needs to be watered, although it's saturated an inch or more down. And that's how we get with plants that look like the first plant that I showed you, because there was no soil structure to sustain that, and the water just sat there and never left. So the oxygen never got a turn to replace it, you know. And the roots don't need only oxygen. The roots don't only need water, they need just as much oxygen. And the only way to get the air down there is for the soil to have structure, for an aeration and drainage, for the water to run through and form a vacuum and pull the air down to the roots. So without further ado, I've got these plants transplanted. I am going to do a little bit of backfill. And then I've got my watering can here. It's pre-mixed up with 2 gallons. I'm not going to use 2 gallons for this 7-gallon container because that is just well outside of the 5% rule of thumb, which is you never water your plants more than 5% of the total volume of soil, you know. So like 100 gallons of soil would be 5 gallons of water. So 10 gallons of soil would be, you know, like a ½ gallon of water. You know, so you don't want to bury your plants, you don't want to pack it down, and you don't want your plants to be like lower than the rest of the soil surface, because when you water it will pool to them and it will begin to drown them out, and it can cause problems around the crown of your plant, which is where the stem meets the ground, like root rot and crown rot. So you want to keep a soil surface level that is even with the bottom of your plant, you know. I don't know if I said that right, but you want the plants to be flush with the rest of the soil surface level. You know, or if anything, maybe a little bit of a mound that they're on compared to the rest of the soil, so they have a natural flow around the root ball. But you always need the roots to be submerged in the soil. Never leave any soil showing. Never leave any roots showing when you do a transplant. I know it seems obvious, but believe me, there's people that is not an obvious thing. So I'm gonna move this camera. All right, so you see what I'm doing here. The sun's just starting to set here, and you know, sunny Woodford, VA, and yeah, man, it's been a very tempered winter here, and it's been late spring frosts, you know, so like it's been an iffy start, like, you know, Farmer's Almanac was dead on with the last frost date, but man, the weather kept getting beautiful and then literally below freezing again after 82-degree days. Like, man, it was confusing getting this summer off to a good start, but I'm glad that I have. If you've watched me talk all of this time, thanks for watching the end of the video. If you doctor your plants like this, they'll all come out like that. These are some of the few things that all plants need. You know, they're not too different from one another. They just have different flavors they want, basically. You know, like, you know, most of them want well-draining, well-aerated soil. You know, so as long as you got some perlite and most of your soil is like medium grade grains, and you know, not like not real fine silt. It needs to be a equal ratio of silt, sand, and clay. So if you think about it, like, they all need to be roughly the same size particles, and then you have small little like forest products that are like slightly bigger than the soil particle wood pieces, and that keeps the soil from compacting and packing the air pockets out, like when it gets stepped on and things like that. So yeah, man, just take care of your soil and it'll take care of the plants. If you stop trying to take care of the plants so much, you know, you'll be surprised. Most of this is taking care of the soil, not the plant. The soil's being abused and we're wondering why the plants are as well. So if you have any questions, please feel free to ask. Leave a comment, a like, share, comment, all that. Love you guys.